Fuel delivery. We're going to talk about gasoline versus diesel. In a gasoline engine, the air is mixed with the fuel in the intake manifold, which means as air goes through the carburetor, it pre-mixes it. As it's traveling down the intake, it swirls, it causes that fuel to mix better, and it breaks those fuel molecules down into a vapor. Every piece of fuel that goes into an engine has to be in a vapor form to actually properly burn. If I take a can of gas and I drop a match in it and I have it mostly covered up, what's going to happen is the match will go out. Because if I put a match into a liquid that's cold and there's no vapors, it won't burn. What actually burns when I drop a match into a can of gas is as the match is falling, there's vapor on top of that fuel, and it ignites the vapor, and that causes it to explode. If you take a full tank of gas and throw a match in it, it could blow up, but usually they don't. But an empty tank of gas blows up because it's just full of vapors. And vapors is what it takes to burn. Use the carburetor or fuel injection. We're seeing fuel injections come down into this industry pretty common now. In order to meet emissions, we're going to overhead valves and fuel injection systems. This industry has to meet emissions just like the auto industry. And so we're seeing more fuel injection, more expensive engines in this industry. The combustion timing is controlled by the spark timing. The spark plug, when it fires, determines when that fire begins in that combustion chamber. The combustion is going to be started from the spark of the spark plug, and so if I don't have a spark, I will not have ignition. In a diesel engine, it's going to be a lot more efficient, and we've seen that little chart that shows how much of a gallon of fuel is actually used in a diesel and how much is used in a gas. A diesel engine is more efficient because it doesn't have the restriction of the the carburetor. In a carburetor will be a venturi, it's a narrowing of the carburetor, and that's a restriction, and so I have less air going into it. At an idle, I have a throttle plate, and the throttle plate is almost completely closed, restricting and blocking off most of the air. And so you have this big restriction in there that doesn't allow very much air to get in there, so it's not going to burn very well. In a diesel engine, we're going to inject the fuel directly down into the combustion chamber, and the only thing that goes through the intake manifold and into that cylinder is air. It's an unrestricted air passage that goes into there. So I can draw in a full charge of air, and then depending on how much power I want, I can meter in and actually put just the amount of fuel that I want to run the engine. But it has maximum amount of air, so it takes very little fuel to actually get energy out of that fuel.
If you have like a carbureted engine, could you change it to fuel injected?
If I have a carbureted and I want to change it to a fuel injected system, it would take a lot of work. You'd have to have something to control the fuel injection system. So it would, unless the engine was designed for both ways, no. So let's say you have a Kawasaki. Kawasaki has a V-twin, and you can get it carbureted or fuel injected. The difference is the intake manifold and then a bunch of sensors. But the basic block is the same, so as long as you change all the stuff on the outside, you could. But then you'd have to have the control unit that controls the injectors, and there's a bunch of other components. It'd be pretty expensive. And so it's highly unlikely someone would want to do that. You'd want to just buy the whole engine or sell it, start all over with a whole different machine. In a diesel, the fuel and the air is actually mixed in the combustion chamber. It's not mixed in the intake tube. It's just air going through the intake tube. It's mixed in the combustion chamber. It's mixed as that piston comes up and heats the air. It causes it to turbulate. The air is turbulating, but it's just air. So you get this violent turbulence taking place. And when I throw the fuel in there, it's thrown into this violently mixing air, and it stirs it up and burns it. The combustion timing is actually determined by the injector. The injector, when the injector actually starts putting fuel into that cylinder, that'll determine when combustion starts. The combustion is actually started by the heat compression. Even if I inject the fuel in there with my injector, if there's no heat in there, it won't burn. Now that's what we talked about earlier today. Was we talked about minimum cranking speed, using the cold starting aids. That's so that we have enough heat that when I throw fuel in there, then it will actually ignite. And if I don't, it just goes out the exhaust pipe as white smoke.